Hello everybody, welcome to part 8 of our build or get dipper with dipfunction. Well guys, you have to rebuild a little bit our switch here. First of all I have to put some other values in there of RF resistor coils. So I have noted them down on this piece of paper, and it will be the same as on the signal generator side. So you know there are two switches on there. So on my desk I have, on my workbench, I have the second deck of the switch I'm using. So I have to take that all off. This part, get all those coils off and replace them with the values I want. On top of that we have to put in this disc. We have to drill the holes, put it on top here so that it fits nicely, and we drill the holes for the bolts, and we widen up this little hole here, and then we clean it up a little bit. We get that all cleaned up here where the holes are, dremel that away so the copper is gone, and then we end up with 3 decks. I'm going to show you the original switch. Just a moment. I have to get that for you. Yesterday I did find some more switches by my supplier, so I was lucky. That was the last 3 switches I did find. So you can see here there are 3 decks, and that's the same switch what is in here. What I will do is then get this middle deck away and replace this with this. Yes. Then we get our resistor RF coil on the front. We connect that up there, so we can have to imagine that this is in this place. We connect that up there, yes. And the resistors what I have on the bench, there are 5 of those resistors, and they have the function. They have the function of reducing the voltage on the screen grid. As I told you before in the previous videos, every frequency, a low frequency, has a bigger amplitude than a higher frequency. In order to prevent oscillating, that the whole system starts to oscillate because of feedback, we have to reduce the working of that valve. So we just need the amplification just big enough that all the amplitudes are nearly the same. Nearly, I say nearly, approximately. So we won't achieve that not entirely, but eventually you will, because if you have different values of resistors. So the values consist of 47K, 100K, and 820K, a 1.8 mech, and a 4.7 mech. So the 4.7 mech represents the lowest frequencies with the highest amplitude, and the 47K the highest frequency. So that you end up with approximately the same amplitude for every band actually. That will prevent feedback and parasitic oscillation, what we have to put up with if you do it that way as it is now. So we did test that. I didn't do that on camera, but anyway, you won't well, see anything on that other than it doesn't work. So I don't want you to see that it doesn't work. I want you to see that it does work. So that's why I going to make some changes in the switch. So I will put in the resistor coils what have to be on there. What I put noted down. I put them in. And then I will make it like I said to you in this configuration. This switch will go out, they will be replaced by this one, yeah, and then we connect up our coils and our resistors. And what we have to do then is the two highest bands, what I saw, they get connected to the 47K. Then the third band will be connected up to 100K. The fourth band on 820K, and then the sixth and the fifth and the sixth on the 1.8 meg, and the 7 and the 8 will be connected on the 4.7 meg. So we have to do that on this switch when connecting contacts together. So 4.7 meg, what was that? 47K, two contacts, 100K, 820K, and then we have 1.8 meg, all two of them, and two of them of the 4.7 meg. So, and on the mother contact, and this one here, they put the voltage on. So when the switch is turned, you get the voltage down what you want on the screen grid for this valve. So every time if you turn the switch, then you get the appropriate voltage on the screen grid. Okay, that's so far as that will go. And if you've done that, today is Shabbat, I won't do anything, just making this little video. I will start off our transformer. I will do that tomorrow. I will start off the transformer. Okay, wind that transformer on 235 volts up to secondary 180 volts and 6.3 volts for the filaments. That will be on here on this transformer. That transformer will I put on this side there. I will mount them there. And there is no rectifying valve. I will use some diodes, and I can do that because when I switch on my power here, I'm still isolated from the power. So unless I switch this little switch on, then it will power up. So you have then the opportunity to warm up the valves without damaging the valves, actually, as it were. So you can damage valves if they are not warmed up. So if you prevent that with that, so you can wait say a minute or two, and then the valves are lit up, warmed up, and then you put the power on, and then the gripper of the signal generator will work, or when I switch on this one, that gripper will work. So that's what we're going to do, chaps. Yeah, we have to do a lot of work still. So, but we're getting near the end. We are very close. So I'm going to do that. So I'm going to make that switch, and when I've done that, I will show you. I think before I put them back, I will show you what I've done, so you can verify what I said. So this won't be the switch. It's the switch that is on there. That will be the switch. So I will get them out, get them in the configuration I told you how I will do, and I will put them back. Show you how I put them back. And then we will test this function. We'll test the function. I won't do that won't do that with the signal generator. I pick up another old-fashioned signal generator from Japanese make. Is that Senwa, something like that? And he provides me with a quite strong signal. What I put on this connection here, that's 100 picofarad or the 5 picofarads, and then we see the deflection of the meter. So the meter will go up to, I set that to 7, and when the system comes in resonance with the signal generator, here will drop down to 1.3 or something like that. So then you can see that it works. Okay, and then we show you some more things what the thing is capable of. So Anyway guys, so far so good. I will shut down the video now and I will do my job tomorrow. I'm going to do that switch and other things, and I will see you then. Okay guys, we go on with our switch. I will show you how I do this. So we have our deck, our first deck here. You see I left some RF coils on there, 2 of them. So that's the highest band, and then we go down lower. Okay, so it's this way. Go around. You have to fold this back. Yeah, you don't get onto the capacitor here on this side when you touch that. So yeah, I took it all off, you can see. That's the only way to get to it. That's the trouble when you build compact. So put that on here that way. Now then you have to demark down those 2 holes. We will do that. There you go, that's 1. And that's 2. Okay, we got that marked off. See how we drill the hole just big enough to get the axle through so that it doesn't move at all. That it can't move, you see. And we take it off. Okay, and now we're going to drill those holes. See how tight this is. We can get it over anymore. So we will drill those 2 holes. Get that bigger drill out of it for a moment. So I drill that up a little bit. See, I have to show you something. So I'll take my pliers, put that here for a minute. Take my pliers to hold on to it firmly. There you go. Put it on the back. Can you see that? Not really. So I'll move the camera back a bit. So now you can see. Okay, I have all those holes. Be careful that it doesn't run away. If I stand up, I can see what I'm doing. Screw. Stick that one down. That way. It's difficult because I have no. There we go. Okay. Now then, we have to get a knife. There's a knife. To clean it up a bit. There's a knife, so we can clean it up a bit here. That way. Well, use a Dremel for that. We go Dremel that away. Don't want that copper near that hole of those. will make capacitance you don't want. So I get this middle hole also cleaned up. See if you don't have any trouble later on of making shorts or something like that, because the high voltage will be on here. So you get the drill again, that big one. I can even get a bigger one than that. Hold on, since I have a big one here, you just fits in here, but I have to have a bigger one than that to get some more room. Hang on. That will do. I have a nice one here. That will do. I will pick that up again with our pliers. You won't hold on to that. That's enough, you see. That's big enough to get it all done. Get that drill out of it again. Put that little one. I don't want it anyway anymore, so I've done all the drilling now. I have to charge up my battery also. Well, I have to clean up the edges a little bit of this. That's nice. Shut it up. So that's it. Now we're going to assemble it. See, that's probably the old bolts that are soldered in there. We put them back in the box and we can use them again. So we take this apart again. Okay. Then just get the small bolt out of it. First, the first one. Just leave that thing in there if possible. And get the other one in. First get that out of. I'll chuck it on the floor, you won't find it anymore. Oh dear. Oh dear. That was the way, isn't it? It never goes as you as it should. Okay. Let's get this pulled in there, because that is the that's the original bolt. Get something else. My fingers are too thick. There we go. Come on then. There you go. That's off. Get the other one off. You left that wire on because this goes on to the anode of the valve. So that's a bit of a reminder. Take that all off. And hopefully I'll be able to keep him on. First things first. Because this is all not off. Get them off. The original bolts, so there we go. Now then, I have to get one of them on. One of them is those standoffs. You need them. Then we put our Let's have a look. We put them in that way, towards copper towards the front. There we go. There's on as well. Put the other standoffs on there. There you go. As I showed you in the previous video, I thought. Well, maybe this video, I don't know. I showed you that, and I want to put up the third deck on there, of the second deck actually. That should be on here that way. Go on then. Okay, be a sport. Get on there. There we go. Sort of checking if our deck is in the right position. No, you see I turned it this and this lip is the wrong way round. So I turned it the wrong way round. So get that nut off again. So you have to pay attention. If you don't pay attention, you're wrong. So 180 degrees the other way. Let's get them on. There we go. Now we're on business. I'll just put it on the same side, you know. See that mother contact is here. There's my mother contact. Here. Something. Get my other nut on there. I'm always afraid this drops on the floor and I can't find it anymore. So there we go. Now, where's my screwdriver? Tighten that up. First by hand, of course. Always do that. You have to make a habit of that, to make sure that it's tightened up by hand. There we go. Get hold of it. Tighten them up. It keeps turning. You have to hold them. I have to hold them. Get my pliers on there, hopefully. Without losing them again. Ah! Dear, oh dear, oh dear. See if I can do it with my fingers. Yeah, that's okay. There you go, guys. Our switch is mounted. You can see, oh, it's exactly what I told you. That middle deck is gone. There's now a separation. Normally you can use the same technique for making a screen, to screen something off. You can do that. But in this case we have to have the voltage onto our coils. And we are going to put on those coils. See, they are not a bit too long. Well, I'm going to bend them over a little bit. And get my other leads. I will shorten them a little bit. Let's cut them down a bit, like that. Not too far. Just cut them up a bit, then with your pencils you move them over onto the copper, like that. Right? Now then, come on. There we go. Just me take him out a bit that way, so well. So now we have our switch here. We have to look. He's on the lowest setting, so we have to go back anti-clockwise. We'll put them. Oh yeah, anti-clockwise. Hold on. It's the other way around, isn't it? Yeah, of course. That's stupid. Have a look here, guys, if I'm right, okay. Something is not right here. What have I done? What have I done? What have I done? What have I done? This there. Did I something stupid? Hold on, guys. Where's my light? What have I done? There. What have I done? I have to think about this. They are the highest. This one is the highest. So I have a look, okay? And go back that way. No, it is not working. Okay, yeah. I know what I've done. I know. This side, anti-clockwise, is the minimum. That is minimum because the P contact is there. So you have more switch capability. So we put them up here. Here. Then we are here, and you have 3 contacts left. You can put some more coils on there if you wanted to. So 3 more coils can go on. So we have 11 positions, and we use only 9 or 8 positions. So what we're going to do next is what I wrote down. Let's get this out of the way. That way. What did I write down? I put in there for those two a 4.7k resistor. Okay. Have a look at this. There's a 100k, 47k. I think it's this one here. Let's have a look. One. That's a 47k. Let's put that hand back. Well, that 47k has to be switched. So what I'm saying to you is the high voltage will be on the mother contact, that's this one. So the high voltage will go via the mother contact onto this ring and come up with here. And we have 2 settings here. Not one. Have to have one more. Yeah. That's it. That's the last one. So we have to get those 2 contacts, but that's go down here. The frequency goes up to 31 megahertz, and the highest frequency is 16 megahertz. So those 2 have to have 47k. Okay, we'll do that. So that is this one and this one. We feed that through here. It shortened this a little bit, but yeah, we can shorten this a bit. Will be easier to handle it. There we go. Have a look. That is the lowest one. Ik heb maar. Oh yes, it goes better met filters. Get them down on here. It's a fast boss. Yeah, come on then. Well, move them over. There you go. Get hold of them. So, put on my soldering iron. So I put that back to 260, something like that. And then we just let that warm up. Then we solder those points. Yeah, and then we fold this back and solder it on with this RF cords, okay? I'll do that the other one way around actually. Let's have a look if we can rectify that a bit. Get it off. Get them out. Yeah. Get them the other way around then. Come on. There we go. Not my day today. Okay, let's just solder one down. Come on. Get my. Okay. Let's solder it then. Let it flow. Okay, now put that one down. Okay, get done. Got the excess away. Now, move this over. We have to shorten this also a bit. Put it that way. And then take our pincers. Fold that over. And we solder those down as well. See if we get them in. Yeah, with a nice headlamp and laying on the bench. And what are we doing? We're not using it. We are in the dark. Isn't that nice? If you have something, you don't use it. Okay. There we go, guys. Check it off for this soldered properly. No, it's not. Just let it flow. There we go. This one too a bit. Okay. Now we have to check if I didn't damage the coils. Yeah. So I get our meter down. Yeah, our own meter. There we go. I'm still using this on the bench. Well, I want to use it because, well, why not? We have it, so we use it. So I'm going to check now if all those this connection is working. That's fine. It's 45. That's 45. Okay, guys, this is working. Okay, this time. Let's have a look. This is which one is the bottom? Have a look. Which one is the bottom? That one is the bottom. So we go around this side. Yeah. That's that one and that one. The next one will be that one. Let's have a look at that one. That's the next one. Yeah. That's one. That's two. Use that as well. Just make sure that I can see this. I have to make sure I can see it. Okay. Okay. Without damaging anything. Okay. So this one position is done. Get them up to the next one. And the next one will be a 100k resistor and a 12 microhenry coil has to be in there. So I'm going to find myself a 12 microhenry coil. Hold on. And then. There we go. I have to measure that. 12 microhenry coil, I think it's one of the green ones. We have that meter here somewhere. Oh, there. There he is. Once more. Let's check this out. Can you see? Yeah, you can. Let's check this out if this is 12 microhenries. Because the colors are not particularly. It's 12. We get one of them off. See something drop on the floor here. Yep. Yeah, we have them. Put them in there again. Get that off for a moment. Get all of those coils. Put that back. There we go. Let's get that coil on. First things first, get them on here. I'll put them that way. I'll shorten them first. First I'm going to clean up that wire a bit. You know why? It's filthy. Look at your thumb, it's all black. Just clean it up a bit, it will be easier to solder it on. Okay. Get that off. Right there. Box it. So. Do the other side as well. I have to cut that off as well in a minute, but that doesn't matter. See those little coils, 7 days, they are stocked up and they lay there for years and they get all blackened because of here you go, have a hole. No, they soldered shut because there was another coil in there before, so I have to heat it up a bit so we can get through. There it goes. Now. That's my lamp. Not enough. I had enough. That's my lamp. I have bad eyesight and I'm working in the dark. That doesn't particularly help, does it? I have my coil. Chuck that down again. Oh god. Where I left that now. Sorry guys, it is not my day. There it is. It is not my day today, so try to do my best. That's obviously not enough. Alright. There it is. It's on. It's not far enough, I'm not satisfied. Oh, it's loose. There's a rest solder on there. Oh. Hold on, let's get that sorted right away. There we go. That's better. You see what the fiddle that is? Yes. If you like fiddling, there's nothing wrong. If you don't like it, you're in trouble. Okay. Yeah, Joe's comforter. You bend that over as well. Okay guys, well I went ahead a little bit, so as you can see I put the switch in there. So we are now ready to put the screening back again down there, so we have to do that to get that wire out of the way. So I have to put those two wires through there. That's okay. That is anode and screen grid, and this is the feed onto the dipper itself, and this is onto the grid of the separation valve. So that will be it, guys. I will see I made some more provisions to screen off the entrance. I don't know if it is, if it was necessary. I think it is, so that's why I put it there. And yeah guys, the next thing we have to do now is to put the screen back in, get the connections up again, get the filaments up again. So if you connect it all up, we will have a little test on camera, and that will be it for this part 8, I suppose. And the next thing we have to do then is, well, I will show you that on camera also, the making of this beautiful transformer. This one here. I'm going to show you that as well on this part. So the next part will be getting everything into place. Get the power supply in. Have to make sure some things we do that on the part 9, and then hopefully that will be the last part 9. Yeah, I think when everything goes to plan. So I have to get this screen on the detector, just to protect them. It's a bit long, I have to shorten them in with the Dremel. I will shorten it and solder it back on, so that should be okay. So guys, that will be it so far. I will come back to you with the completion of this section, and then we'll do a little trial with the meter, see if he oscillates or starts oscillating or on feedback or whatever. You shouldn't do that. I got all those resistors, and so the actual screen grid resistor has been removed. So according to calculations, those 4 resistors came into existence to replace that. So we have different values: 74, 47k, 100k, 680k, 1.8 meg, and 4.7 meg is in there on the screen grid, so to reduce the voltage on there. Okay guys, so that will be it for now. We'll come back to you. Okay. Okay, you can see I put everything in, and we're ready to go. So yeah, put our screening on, so we have no feedback on there anymore. So you can see everything is into place. Yeah guys, well, the next thing we have to do now is testing if he's oscillating by itself or not. Okay, so I put on our leads. Let's have a look. How are we going to do this? Have to turn them around. See, the problem is my power supply on the other side. Okay, hold on guys, I'll connect them up. Okay everybody, I just connected them up, so you can see the meter in front of you. So Let's get some power onto it. Let's have a look. Just get this valve glowing. Yeah, that's okay. So we have no signal generator on there yet, so we just have to see how it goes. Okay, just put the main voltage on. Just have to warm up also a little bit, so we get to 180 volts. So there's no power on there except when I put this switch up. So he's coming up now, and there we go. You see, our meter is deflecting. Yeah. And there is no oscillation. You see, the meter is not dipping at all. Everything is working normally, so that's okay. But the next thing we do now is to connect up our signal on there, and then we see from there. Okay, well, so I'll get that sorted, and then I'll come back to you. Okay. Okay, everybody. I've got my signal generator here. I will power them up. See, we have to, well, as you can see this, no you can't, you have to move it up a bit. So, see here, there's for banana plugs. So I've got myself some things here. I'll shove them in there. Oh, that's it. Put them on here. That's it. Then we connect those clips on here. There we go. And now we connect them up on our entrance from the good dipper. And get some voltage on there again. Hold on. Just well, let that come up again. So I switch everything off, guys. Let's see what, there we go, okay. Let's switch this thing on. There we go. That's, I think he will dip anyway, so it is in 3.5. You see, he's coming up. See that? You get the dip. He's working, guys. We can try another frequency, so look a bit lower. See what he does. The dip is, it's the same. The main part, guys, is that he doesn't go bonkers. That he starts to oscillate. He doesn't do that. Even lower than that. You see that? If I turn this, and that's the intention. So now we know what does he say. It is 1.7 megahertz. Yeah, he's between 1.25 to 2.4. So he's in between that. So you can see that it's working. Okay, guys, we're there. It's working. That's working well. Okay, we switch the voltage off. Well, the next thing you have to do now, guys, is get the transformer in order, and we go from there. So we accomplish our mission. I promise you I would do that transformer on this part. I don't think I'm going to do that, guys, if you don't mind. Anyway, there's not much to watch anyway, so what we're going to do next is cover the thing up. So you get them boxed in, get the transformer, get the power supply going, so we don't have all those leads anymore, because if I have to do anything, I have to screen them all off. So yeah, I have to do that. Anyway guys, thank you to be on board, thank you for watching, thank you for your interest. As you can see, we accomplished our mission on both sides. This side is working, this side is working. So next thing you have to do to get them together working, we need the power supply. So and I have to box them in, otherwise there's no point of doing this. For your information, if I use this signal generator on the radio or something like that, this thing blasts through everything. Really, it really blasts through everything. You don't even have any control whatsoever. That's very nice. That the main reason is because of this lead. That's the main reason. If there would be another connector on there, like a BNC or something like that, you could be even possible you could prevent that. But then again, there's nothing you can do about that. Okay guys, thank you for being on board. And if you like the videos, you give me a thumbs up and subscribe if you want to. So anyway, give me your comments. The comment section is open, so if you want to give a comment, you are welcome. So what I will say, have a nice day guys, and I'll see you the next time around, okay?